So in this session, I am going to talk about an interesting concept, that is type conversions. Now what exactly type conversion is? So type conversion by name basically means converting one type of data to another. So let's see an example, and hopefully then you will have more clarity. So suppose I am creating a char A, right, and I am writing something like this. I have not put a semicolon, which is why it is throwing an error. But what do you think? A statement like this, will it work or will it not? So now let's put semicolon and see. So a statement like this is absolutely okay. This is perfectly fine. So on the right hand side you have a character, on the left hand side you have an integer, right? You are trying to convert a character to an integer, right? We know characters deep down have their ASCII values associated with them, so which actually makes them similar to numbers, integral numbers. So a statement like this is perfectly fine. And if I'll try printing I, it is going to print 97 to me, because I is storing the ASCII value of A. Right? So something like this is absolutely okay. A conversion like this is absolutely valid, because whatever you have here is a char, right, and char is a 2 byte long storage, and then what you're trying to do is copy this char to an int, and int is a 4 byte storage. So whatever value or whatever number you can store in 2 bytes, you can definitely store that number in 4 bytes. So system doesn't really has any issue with that, right? But what if I try to do opposite? Let's say I try to convert back. I'm writing something like this. Now I has 97. 97 can easily be stored in a character, but it is still throwing an error to me. And the reason it is throwing an error is because it says that a type does not match. You cannot convert an int to a char, because this time I am trying to convert in the opposite direction. So I am trying to insert a 4 byte value into a 2 byte space. Right, so whatever is there in a bigger bucket, you're trying to put it into a smaller bucket and pour everything into the smaller bucket. So you cannot really do that. In case of 97, obviously it can be stored in both integer and character easily, but compiler does not always trust that. Compiler says int is capable of storing bigger values. So what if you are trying to store a bigger value and converting it into a char? So this is something which is not really allowed. This is something which will throw an error, and converting this way, storing a 4 byte value into a 2 byte space will throw an error. So a conversion like this is going to give you an error for obvious reasons, right? It's logical enough. So, but still, if you are pretty adamant and you say no, I really want to convert this, and then if you want to do this, what you can do is use explicit conversion. Explicitly specify that you want this value as char. There can be data loss, obviously, because there can be a bigger value which you are trying to store in a 2 byte space, so there can be data loss. But if you're writing it explicitly, system says okay, this is what you want to do, so let's do that, right? So this is explicit conversion. A conversion happening here was implicit, because there was no eventual loss of information, and this was very easy to do. So implicit conversion is pretty easy to get done. But if you want to convert other way around, store a bigger value into a smaller container, put a larger value in a smaller container, and then you will have to convert it explicitly. So conversion like this is going to be explicit. Right, so I hope this is clear to you. So in fact, if I try to do even something like this, let me just come in this and do it. So ch is equal to ch plus 1. If I'm doing something like this, even something like this will not work. Now the reason this is not working is when you do this is an integer involved in the operation, right? This is a character. Characters ASCII values are numbered. So ultimately the result is going to be an integer, the bigger type. Result is going to be of bigger type, I should say. So bigger type is int. Now right hand side evaluates to an integer number, and you're trying to store that integer number into char. So this is something which will raise an error. And so let me just clear it. Right? So this was one point. If you really want to cast, you will have to cast it explicitly. Store everything like this, cast it to a char. Explicit conversion is there, so you can obviously do something like this. Right? Now let me come in this and explore a couple of other options. You know about int and short by now, right? So you have int like this, or maybe just an int for now, and let's create a short value like this. So int I is equal to s is perfectly okay. Short is a 2-byte space. You want to store it into a 4-byte integer. Makes sense. You can do that. But the opposite or the vice versa will not hold, right? So int is a 4-byte space. You are trying to actually put a 4-byte value into a 2-byte space. So this is going to throw an error. If you really want to do this, again, explicit conversion is an option for you. If you really want that I want to convert it into a short, you can definitely write something like this and system will say, okay, this is what you want, I'll do that, right? So this implicit and explicit conversion thing, I hope this makes sense. Another possible case is when you are trying to write something like this. So 10.6 actually is a double value. So by default, all decimal numbers are double values. So this is a double value. Now you are trying to store a double value into an integer. Double is 8 bytes, integer is 4 bytes, and in fact it is capable of storing decimal numbers, which integer is not. So definitely when you're trying to do that, there is some loss of information that will take place. So system will directly not allow you to do that. But typecasting, explicit typecasting is another option obviously that you have in case you really want to do that, right? So this is something which you can do for sure. Now let's play around a little more. You know float, right? So by now we know that there is a float data type as well. So if I write something like this, it is throwing an error. Now let's analyze why is this error there at first place. So the reason we have this error is because all decimal numbers that we write by default are double. So whatever decimal number that you're writing are double by default. So that means this is a double number, and in fact I'll discuss it in step by step. So when you're writing something like this, my bad, there is a spelling mistake. So float f is equal to 1.7. So this entire line doesn't execute in one go. First of all, right side is executed, and this 1.7 is stored in a temporary memory. So this is a temporary memory, and this temporary memory is of type double, because by default all decimal numbers are of type double. That means this will be a 8-byte long memory, right? And now when you are trying to create a float, which is a 4-byte long space, although I have drawn it wide, let me just cut it. So this is a 4-byte long space, right? And now what you're trying to do is you are actually trying to copy these 8-byte content into the 4-byte space that you have, because by default it is double. Now you're trying to convert that double to float. So this is something which will throw you an error, which is why previously also I said that if you really want to do that, write f here. That means it will create it as a float, or you can now explicitly cast. So if you want, you can do an explicit conversion as well, right? So this is something which is there available to you, and you can try that. So I really hope that the concept of explicit and implicit conversion is clear to you, how things work, how the flow is, how character conversions are taking place. Okay, so with this I just want to discuss a couple of more things, and let me comment everything here. So while using operators, suppose you are using an operator, and I'll put a couple of print statements here. So you're writing 4 plus 3, this is 4 plus 4, let's say this is a valid statement over here, and then I'm writing 4 plus 4.5, this is another statement that I have here, and I'm writing 4.1 plus 4.4. What do you think will be the output of all these statements? So first statement, answer will be 8. Second statement, answer should be 8.5, and fourth statement, answer should be 8.5 as well. Okay, and this is what is expected. Now if you'll notice here, when you are adding two integers, answer will be an integer. When you are adding an integer and a double, answer will be of bigger type, which is a double. If you are adding two doubles, things are pretty much sorted, answer will be a double. And we even discussed this case, right? 2 by 5, 2 is an integer, 5 is an integer, answer will be an integer. What if I want the decimal value as well? So what if I want 2 by 5 in decimal? So if I have something like this, so if I'll write 2 by 5, this is going to print 0 for sure, right? So, but I don't want that, right? So what you can do is cast one of them to double. So now 2 is double, 5 is integer. So an operation involving in double and integer will give you a decimal answer. Or you could have written it as 2.0 as well. Even that would have been okay. So that would have given you a decimal value as well. Right? So I hope the entire logic around type conversions, casting, operators involving this conversion implicitly is clear to you. Thank you.